Let's imagine we've walked into a network and we've just connected our laptop to the network, and we need to figure out what's out there. What could we potentially access? So the first thing we need to do is see what IP address we received on our computer. So here we see running IPAdder that we are 10.109/23 with a broadcast address of 10.11255. So we know we're on a 23-bit subnet. So let's see what's out there. And for purpose of this demo, I'm not going to scan the entire /23. I'm just going to do the first little chunk of it so we can just get an idea of what's going on. Let's do an nmap, spell it correctly, of course, -n -sn 10.100/28. So what did I just do? I did an ARP scan. The first -n right here says don't resolve numbers to names. And this is our scan type, it's an ARP scan, and we're going to scan this particular subnet, /28. It's the first 15 addresses in that subnet. So we see that some hosts are up. Host is up, host is up, host is up. So we have hosts available and for talking to at 1, 5, 9, 10, and 15. I myself on this computer am 10.109. Now let's do a TCP port scan. And I'm going to do a connect scan. It's not passive, it's an active scan. I'm actually going to complete the three-way handshake for TCP. So let's do an nmap -st, that's our scan type is TCP. And I'm going to specify a port range. Let's do ports 1 through 1000. And I'm going to change the timing. I'm going to do some insane timing. And then finally 10.100/28. So let's let this run. There's several different timing options available to you, from polite to insane. Insane is the fastest one, and it's going to generate these packets as fast as the underlying computer is able to do. All right, let's take a look at our output here. Let's scroll up a little bit to where we first executed the command. It looks like over here we had an error for .15. It was transmitting a little too fast. No worries there. All right. 10.101 is up. There's a good chance that is our default gateway. If we were to look at that IPAdder output again, it's not going to be in there. Let's do an IP route. There we go. Default route 10.101. So that is our default gateway. Let's scroll up here. We got 10.105 is up and online. Looks like it has SSH available. So is this a Linux or Unix type system? Me knowing what this network is, I can tell you that that particular host is a VMware ESXi instance. So it is listening on various services required for VMware to operate. 10.109, this is localhost. Looks like it's a Windows system. It is not, I know that just because it's my computer, and it is running Samba for a future demo. We have 10.1.0.10, looks like it's a web server, and 10.1.0.15, it's a printer. Let's make this the focus of our investigation. So we see that it is listening on LPD, that's line printer daemon 515. By the way, a little side note, cat etc services, if I spell it properly. This file is distributed with most Unix and Linux type systems, and it's for the system to do that translation. If we look for 515 in etc services, we can see, so that translation that was done, that I turned off with the -n, I did not turn it off for that TCP connect scan, and it did the translation by using this file. So it saw that port 515 was available, it consulted this file and said that is the printer service. So that's where that output of printer came from. All right, let's just go ahead and do an nmap st with no other options on 10.1.0.15, that printer, or what we think is a printer. We didn't get any more useful information except for JetDirect is available. So when I ran that previous command, I had the P1-1000, which we see right here. So this is the port range that we're going to scan. That does not include 9100. By running nmap st with no other options, it scans through a list of commonly available ports, which includes the JetDirect port. So we have a printer here. I wonder what kind of printer it is. It is listening on 443. Could we banner grab that? Let's do an nmap -sv and p0 and 10.1.0.15. So p0 says don't ping. The default operation of nmap is going to check that the host is up and running before it scans it. This is a way for nmap to be a little bit more polite. So we're not going to ping it, we're just going to assume it's up and start firing off the packets. And we're going to try to get some version information from this particular device. So let me go ahead and execute this, and this particular scan is going to take a little bit longer. You'll notice that it says host discovery disabled, scan times will be slower. Also, when Nmap is running, if you hit the enter key, it will show you an estimated time to completion. So here it says 20 seconds remaining. I know that this particular scan is going to take approximately 90 seconds or so. Okay, the scan has completed and we see that we are talking to a Canon printer. And I know that to be true because this is the printer in my home. All right, so we ran through several options with Nmap. One final thing I want to point out is Man Nmap. So this is the manual documentation, or the user manual, the man page for Nmap. It is very helpful. It has a whole bunch of examples in here. It shows you all your scan techniques, all your command line switches, firewall IDS evasion techniques. Let me go back one page, and here's some examples of commands you can run. This one is actually kind of fun. This will do a random scan, so it will generate IP addresses on the fly. So it's looking for web servers out on the internet to potentially connect to. And you can find some fun things. I'm not going to be able to paste that. Let's go ahead and run it. Nmap -v -ir 10, let's do 100, -p0 -p80. Parallel DNS resolution of 100 hosts. And it is trying to connect. So we already found one, open port on that IP address. Some interesting DNS resolutions in here. So play around with Nmap. It is an essential tool in your toolkit for discovering what is available on the network. Going back to the Canon example, we know we have a Canon printer there. If we go to our vulnerability database and search for Canon printers, what exploits might be available for those services that we are able to talk to?